Okay, so in this video, I'm going to introduce some measures of variability based on percentile ideas. So in case if you don't remember what was percentile, please go back to the previous previous lecture video, maybe the last video from chapter 3 or last two videos, just to remind you what was a percentile. The first measure of variability is the range, which is pretty intuitive and simple to calculate. It's just simply the difference between the maximum and the minimum. So remember, a measure of variability is to capture how much the data varies, right? So the most intuitive measure would be just the distance, the area, the how wide the range is. That is the range, right? The greater the range is, the more variation in the data, right? In our example, in Honolulu, if you have like monthly average data, Honolulu's hottest month was 87.9 and coldest month was 66.3. So their difference becomes 21.6. That means in Honolulu, the monthly average temperature varies only 21 degrees a year, right? The coldest and the hottest month are different by only 21. But in Phoenix, that's 50 degrees. The hottest month and the coldest month differ by more than 50 degrees. So these numbers, by comparing 21 and 50, you can easily tell Phoenix whether in Phoenix is much more like volatile, like a variable, right? So it's pretty simple to calculate, intuitive to understand. However, a big problem is that it's extremely sensitive to outliers. For example, just assume that you mistyped 66.3 as 663. So somehow you forgot to put a dot here, right? So suddenly it becomes the maximum 660, right? So then the range will be nearly 600. Somehow, just one error. I don't know how much data you have. No matter how big your data is, say you have billion observations, but you make one error which affects the maximum or the minimum, then that will totally contaminate your measure. The range can be affected, like 100% affected by a single error or a small number of sample. So similar, like if there are outliers, super rich, just most of the people are here, but there was one super rich out there, then the super rich just makes the range from here to this much. So small number of observations can make a huge difference when you calculate the range. That is a big problem. So, have a look at this example. In this graph, range is 3.67, right? So it's a good-looking data. But if you just happen to have one outlier here, suddenly this much range is added. I don't know, maybe say, suppose here are a lot of data here, but just one error or outlier may occur, then your range can be misleading, right? It's not. So basically the data does not is pretty much the same, but just one observation can make this much difference, which is not ideal, right? So then how can we fix this problem? We are going to modify the measure range to be more robust against outliers. That's interquartile range. Again, if you don't remember what was percentile, you should review chapter 3 first, right? You may pause this video and review first. And remember, there was a special name for 25, 50%, and 75 percentiles. First quartile for the 25 percentile, and third quartile for 75 percentile, and 50 percentile is median or second quartile, right? So it's if you divide the data into 4 equal parts, then each cutting point will be a quartile. Anyhow, the interquartile range is defined as third quartile minus first quartile. So let's go back to the definition of the range. Maximum can be understood as 100% percentile, and minimum is 0 percentile. So 100 to 0. But outlier does affect the range too much. So what we are going to do is we are going to delete bottom 25% and top 25%. So you may understand it as we assume that bottom 25 and top 25% can be outliers, right? So, and then you only have middle 50% observations, and then just use those middle 50% observation and recalculate the range within them. So that means in the end, the maximum of the middle 50% will be 75 percentile, and minimum of the middle 50% will be 25 percentile. So it is a kind of a range. It is a variant of range, but calculated after dropping the bottom 25% and top 25%, so that even if there is an outlier, it will be ignored. So no matter what, even if it's from the bottom or from the top, we are going to delete them first and then use middle 50%. So it is much more robust, stable, reliable against outliers. So the idea is pretty similar. This comparison goes pretty parallel as the comparison between the mean and the median. Mean is the number one measure, most commonly used measure, but one critical problem, especially in economics, is that the mean is very sensitive to the outliers. So in case you expect some outliers in your data, then you may want to check the median together with the mean. Similar, interquartile range is pretty robust against outliers. So this will be a good measure of variability in case you have outliers. But of course, range is not. Range is most sensitive, but interquartile range is pretty stable. So similar as median, right? And then this is the idea. We drop bottom 25%. And then the cutting point is here, first quartile, and top 25% is this area. So we cut here, and then we only have middle 50%. So as you can see, it doesn't matter if this outlier exists or not, right? Anyhow, it will be ignored. It will be dropped. So in the end, we are using this data. So interquartile range is captured as 1.13. So that is a new measure, or more advanced measure than the range. So it is stable against outliers. Now, so far, I briefly introduced two measures of variability based on percentiles. But actually, more popular measures of variability are based on mean, but well, which is coming soon, which is coming in the next video. But like so usually we are going to use mean with standard deviation coming next. So standard deviation is the standard pair for the mean. But when there are outliers, we usually use median and interquartile range. So usually they go as a pair, right? So because we are using them because of outliers, so then we have to like take outliers into account for both measures. So we learned these special measures first. Next, I'm going to introduce standard deviation, right? In the next video, I will show you how we define standard deviation. Okay, thank you for watching, and see you in the next one.